Good morning, good afternoon, or good evening. I don't know your life. I don't know when you're watching this. As you can probably tell, unfortunately, I am not Mr. Fritz. I am Miss Honerbrink, and I'm going to be reading these SI units and measurements. This is one of your assignments, so you should probably take notes. You can watch this video, or you can just exit out of this and read those notes on your own. But if you would like a fun and exciting read along, stay on here with me. So, SI units and measurements. The SI system has a base unit, or a standard unit, for every type of measurement. SI stands for Système Internationale, which is French for International System. The SI units started in France in like the 1600s, and in the late 1700s, after the French Revolution, they all had different kinds of ways of measuring stuff. So the French Revolution kind of got them all to start using the same ways to measure things. And that has since branched out to the rest of Europe and to the rest of the world. The SI base unit for length is a meter. A meter is about the width of your door in your house. Usually like your front door. I measured my bedroom door and that was only 75 centimeters, but my front door was exactly a meter. In order to measure mass, we use grams. An example of a gram is a large paper clip. Mine is pink. It does not matter what color it is. It's probably about a gram. The way that we measure weight or force is with a Newton. So that is actually the force exerted on Earth. And our weight will be different on different planets or just throughout the universe. Newton is named after Sir Isaac Newton. You may have heard of him. He sat under an apple tree. An apple fell on his head and he was like, whoa, gravity. Volume is measured in liters. You may have heard of gallons, quarts, pints, but the SI base unit for volume is a liter. And I have an example of a liter. I was looking through my apartment and most things were measured in gallons, but I found this bubble bath, which is exactly a liter. So this is the example of a liter. The SI base unit for temperature is Celsius. You may have heard of Fahrenheit, but Celsius is a little bit easier to understand because 0 degrees Celsius is freezing and 100 degrees Celsius is boiling. Time is measured in seconds. Electric current is measured in amperes, which is named after some French guy who dealt with electricity. Amount of substrate in an item is measured in moles. You'll probably learn more about this in your chemistry class because it has to do with atomic mass. Mole is short for molecule. That's probably the most you need to know about moles right now in 6th grade. And light intensity is measured in candelas, which is Latin for candle. And that is the light intensity of a basic candle. So if you get a basic candle and you light it up, that's 1 candela about. Because we want to use SI units to describe both the distance around someone's bicep and the distance around Earth, we need to be able to change the size of unit to fit that measurement. Scientists use a system of prefixes that multiplies the base unit by factors of 10. Just by switching the prefix, an SI unit can be used for measurements big and small. So some of the SI prefixes. So let's start in the middle at the base unit. So a meter or a liter or a gram would be the base unit. We don't need a prefix on those. A meter equals a meter. If we put the word deca in front of a meter, that would mean 10 meters. If we put the word hecto in front of meter, hectometer, that would be 100 meters. If we put the word kilo in front of meter, kilometer or kilometer is 1,000 meters. Or if we put the word mega, it would be megameters. which is 1,000,000 meters, and gigameter, which is 1,000,000,000 meters. And if we go down from there, a decimeter would be 0.1, or there would be 10 decimeters in a meter, 10 or 100 centimeters in a meter, 1,000 millimeters in a meter, and 1,000,000 micrometers in a meter, and 1,000,000,000 nanometers in a meter. You can also use this as a base unit for grams or liters. The most common prefixes that we use would be kilo, so for kilometer or kilogram, or we don't really use kiloliter, but kilometer for meters and grams. We also use centi and milli a lot, usually for distances or for volume. So a centimeter, I have a little measuring tape right here. So a whole meter is this is a whole meter. And a centimeter is about that big, and a millimeter is about that big. The width of a dime is a millimeter. Also, so like I told you this before, this is a whole liter of bubble bath, some eucalyptus bubble bath. I also have 10 milliliters. So 10 milliliters is technically a centiliter, but we don't usually call it a centiliter. But this is my little essential oil, also eucalyptus. I think I like eucalyptus. 95% of the world uses SI units as the everyday system of measurement. That 5% consists of Myanmar in Asia, Liberia in Africa, and the United States of America. And we all use imperial units. So like inches, feet, pounds, that kind of stuff. Types of measurement. Length is the distance between 2 points. Volume is the amount of space that something occupies. And mass is the amount of matter in a liquid, solid, or gas. Weight is the force exerted by a mass. So remember, this is different than mass. When you measure someone's weight, you actually measure the force that they exert on the earth. So mass is the amount of matter in an object, where weight is the force applied by a mass. So weight relies on gravity, but mass doesn't. For example, the moon has less gravity, so objects weigh less there than on the earth. And mass always remains the same. Weight changes if you're on a different planet or in a different part of the universe. Density is the amount of matter in a volume, and temperature is measuring how hot something is. The SI unit for temperature is technically Kelvin, but most scientists use Celsius to measure temperature. Kelvin doesn't have that little degree symbol on it. Celsius does, like Fahrenheit. Sink or float. Something denser will sink below something that is less dense. So when oil is poured into liquid water, it floats on the top because oil is less dense than water. However, a rock or stone sinks in water. That means that it's denser than water. So water has the density of approximately 1. Oil's density is less than 1, and a rock's density would be more than 1. Some tools that we use to measure distance is a meter stick, which is a little bit longer than a yardstick, a trundle wheel, which actually is used to measure long distances. So you would roll the trundle wheel on the ground, and after every time it reaches a meter, which is actually the circumference of that circle. So this whole circle is a meter. The trundle wheel will make a clicking sound, so you just have to remember how many clicks it is, and that's how many meters it would be. A tape measure is also used to measure distances. It's mostly just like a pocket-sized meter stick, except longer. So this would be for something that's hard to measure using a meter stick, such as the distance around a round object. Volume is measured in a graduated cylinder. A cylinder is marked on the outside with little ticks to indicate how much fluid that it contains. So you take the volume by reading from the bottom of the meniscus. And you got to make sure that you're reading it from eye level. So like in this picture, there is some water in a graduated cylinder and there is a curve because it sticks to the sides of the graduated cylinder. So you would measure from that bottom of the meniscus. So in between 30 milliliters and 40 milliliters, you can see that this is 31, 32, 33, 34, 35, 36, 37 milliliters. In order to measure the volume of a solid, usually a square or a cube, you would actually simply measure its height times its width times its length. So the equation for volume of a cube is length times width times height. In order to measure the volume of an irregular solid, you can use water displacement. So the difference between new and old volume measurements is equal to the volume of an object. So here in the picture, we have about, let's pretend these ticks are milliliters. There's 10 milliliters of water, then we add this scribble or a solid into this graduated cylinder, and the water level goes up about another 10 milliliters. So that means that this solid inside the graduated cylinder has a volume of 10 milliliters. So it had 10, it went up 10 after we added the solid, so that means the solid is 10 milliliters of volume. Mass is measured on an electronic balance. So you would zero out the balance and put an object on that pan and read the mass. You can also use a double pan balance. This is usually useful for when you know the mass of something in one of the pans, and then you can compare it on the other pan. If you're measuring something that needs to be in a container, you can put the empty container on an electronic balance and then zero it out and then add another item, add that other item after, and then you'd see the difference. Or you can actually just subtract the weight of the container afterwards. A triple beam balance also is used to measure mass. So this works like a double pan balance, but instead of using something that you already know the mass of on the other side, there is little sliding weights that either weigh like a gram or 10 grams, and that would help you figure out how much your item weighs by sliding the weights, called riders. Density is measured by the amount of matter in a certain volume. So you can calculate density by measuring the volume and mass of an object and then just dividing them. So density equals mass divided by volume. Time is measured using a clock or a stopwatch. If you're just using a regular clock, you would subtract the start time from the end time to figure out how much time has elapsed. Or you could just use your phone and go to the stopwatch app. And temperature, last but not least, is measured from a thermometer. So a thermometer can be digital or it can be liquid. And when taking the temperature, you got to make sure that the bulb or the tip is in the middle of the liquid that you're measuring and it's not touching the sides or the bottom in order to get a correct measurement. That is it for today. And I hope you guys had fun listening to me talk about different ways to measure stuff using the SI units. Bye.